We'll be looking at the supporting valley rafter 3B. This comes off of the ridge A. The bump out span is 12 foot 8. Half that is 6 foot 4. Since this is a right triangle, this dimension here will also be 6 foot 4. The remainder is 3 foot 8. You add those together and you come up with 10 feet, which is the total run. All right, looking at the detail here, this is a supporting valley rafter. Comes off a ridge beam A. And this is the 3 foot 8 run that we just talked about. That would make this dimension also 3 foot 8. Since this is a right triangle, there's your framing point. We're going to be looking at the layout for ridge beam A now. This is your rafter reference layout 5A. From the center of that rafter reference, indicated in red, is the layout lines for the supporting valley rafter. That's 5.5 inches wide, which is 3.5 inches times 1.414. There's your supporting valley rafter here. Span is 20 feet, so your total run is 10 feet. Taking a look at our sample worksheet now. 3B is the valley rafter with a 10-foot total run, 18 unit length. The fascia we mentioned was 2 feet. This is your supporting valley rafter layout. Make sure you set your framing square to 6 over 16.97. The layout's going to be basically the same as your valley rafter that we looked at earlier. There can be some minor differences. So we've got the mathematical rafter length, which will be 15 feet. And then your mathematical overhang length will be 3 feet. This is your cheek cut. We'll take a closer view of that. It's a single 45-degree bevel cut. And that setback will be half the rafter thickness. There's a detail view. There's your supporting valley rafter. 3.5 inches thick. And let's take a closer look at the math here. We have your setback, which is going to be equal to 1 inch. We've looked at this formula before. 1/2 the ridge thickness times 1.414 equals 1 inch. Your cheek cut is half the thickness of the rafter. All right, now we're going to be discussing this chamfer. This may seem a little bit nitpicky, but it can pose a problem if it's not dealt with. There's a 3D view of this. This is without a V cut, but this is with the chamfer. We'll explain why the chamfer is necessary in just a minute here. Let's take a closer examination. This is your supporting valley rafter. You can see where it has the chamfer cut in it. This is without the chamfer. And what's happening is that section of the valley rafter is protruding above the roof plane, which is not good. There's a cut through the rafter. There's the supporting valley rafter. This is without the V again. There's a height above plate line. And you can see the bottom of the roof sheathing. And where the chamfer cut is, that's where it protrudes above the roof. at a distance of 5/8 of an inch. So what you have to do is you set your saw angle and just zip that right off. Here's the explanation of why you have to do that. The chamfer is required where indicated on the plan, that's between ridge beam A and the shortened valley rafter, due to the top of the supporting valley rafter protruding beyond the roof sheathing plane. We've looked at this raise V formula before. That, of course, was the cross-cut view. Now the length of this chamfer cut goes from the framing point to the chamfer reference line. It's on page C9. Let's take a closer view at this. Okay, we talked about that 3'8" run before. That's from the framing point to the chamfer reference point. So what you'll end up doing is multiplying the chamfer length by the unit run of 18 to come up with the mathematical run. So here's the math. 3'8" times unit length of 18. So the mathematical length is going to be 5'6". And that's what you see right there. Now if you incorporate that with the V, here's the V, this is option B, without the chamfer, you can see that that section still protrudes above the roof plane. So you should really apply the chamfer whether using the V or not. This is what it looks like with the V and with the chamfer. Now if you want to cut the V, this is how you do it. This is the cross-section view. There's the V cut. So you do the V cut for the entire length of the rafter, and then you just do the chamfer in the area that was indicated. If you decide you want to do the V cut, just follow the same procedure that we did for the standard valley rafter.